I'm James. I'm another JavaScript developer. I'm actually DevOps at the moment. But yeah, so what I really want to do with this talk is to actually take some of the building blocks that Andreas and Stefano have actually described in theirs and try and show you a practical example, actually build a very small microservices application, using some of the functional tools, some of the functional building blocks that they've described, So, so just in terms of that, I'm not going to read out the sentence of what a microservices is, but for the intents and purposes of this talk, we're just going to create a very small application which is going to perform just have one single unit of responsibility and perform one single operation, So one thing we have to think about when we're building a Microsoft application is how does functional help in this kind of sense, how do we want to think about how we want to build this application using some of the functional patterns, So what we do here is that we want to describe these as a set of functional patterns here. So if we just describe one single endpoint in an application, we could describe it as this. We could say it's basically a set of operations that we want to perform on some sort of incoming payload. We want to execute it asynchronously because it's all time-based. And we want to have a defined response. So here is either success or failure, and be able to deal in the application, deal with both of these responses in a certain way, So for this example application we're going to be building, it's going to be a very simple application, Talk Finder 2000, which we went out and bought the domain for. So it's going to be like, we're just going to have a data store with a set of LNUC data. So it's going to be search for all the LNUC talks, and then also retrieve data from another data store which has all the speaker information about all those speakers, and return all that into a result set. So if we think about it, we can actually describe this as three separate operations, So the first one is we go find all the talks when given a search term, So if we get some sort of plain search text, we just want to search throughout all the Elasticsearch, in our case, Elasticsearch data store, find all those talks, and then go find speaker data about each one of those talks, and then join them into a result set. So if you think about it, we can just describe this as three separate operations. So if you have a very high-level overview, I'm not going to actually put any code in these slides, but what I've got here is basically a description of these as type signatures. So at the very top, we can actually think about this entire microservices as just simply one function, So here we're going to take some sort of take a talk query, which is some object with some search term inside it, and really we're just going to perform some sort of asynchronous action, however that may be composed, and return a result set, which is all the talks embedded with speaker data. So we can break this up into a set of operations, and one of the first ones may be we just go find the talks. So we go query some data store and return a list of talks back from that. So here, if we look at the type signature, it takes that talk query and returns a future which resolves to the list of talks. And then we have our second operation, which is just to take those list of talks, perform another query against our Mongo data store, and embeds those speaker data into that list of talks. So you can see how we can compose and combine all these operations to finally fit the type signature of our complete service. So if I just give a quick overview of the data that we're kind of dealing with here, So our talk objects are basically made of title descriptions and a speaker property, which here is our GitHub handle. And we have an array of speakers which have that handle property which matches to that same GitHub handle, and all the information about the speakers. And this is the result set that we actually want to end up with. So here it's talks embedded with speaker. All it does is that it took the speaker object and just assigns it to the speaker property in that. So it's really just combining the two. But we need to orchestrate this because these are two separate operations. So let's explore our first asynchronous function, So here we're going to do this, and we need to do a post-transformation on the data that we get back. So find talks. We look at the type signature, talk query returns an array of talks, a future type of array of talks. So here we just have our Elasticsearch function, takes that talk query, but it returns it into a result set that's a bit obfuscated. Yeah, this is our result that you would get back from doing an Elasticsearch operation. Yeah, so there's an object, and here deeply nested into the body is the actual talk values that we actually care about. So we need to get hold of, for us to conform to this type signature, we need to extract all that talk information from that object. And therefore, we need another function that can deal with that. So here we have past results. Here it would take the resolution of that future, it would take that object and then extract out the talk values. Yeah. So we need to pluck all these values outside of this object. Yeah. So we're going to end up having to compose all this and join that together at the end. But I'll show you in the code when we do that. And then we have another asynchronous operation. This time it's going to be a pre-transformation. So basically it's going to perform, we need to take some data, perform some passing on it, and then actually feed that to an asynchronous function to actually get the values that we need. So find speakers from talks basically takes that talk array and then does some sort of asynchronous operation and returns a future type of all the speakers. So here we have a particular standard Mongo query find. So we're going to take that. This is the pre-transformation. Yeah. So we got a list of talks, and what we really want to do is that we want to take that talk and pass it into an object that we can feed to a Mongo query. Yeah. So that function, and then we want to actually take that speaker query object that we've generated and then pass it onto our Mongo client library to actually get the result set that we care about. So here it just returns the various speakers. And finally, we want to join these two together. Again, we have to conform to the type signatures that we were talking about. So here we're going to take that array of talks, and then ultimately we're going to join these together and return the talks embedded with the speaker data. So we've got to join those two those asynchronous operations together, and we can do it like this. So remember, we've got our second asynchronous operation, which takes the talks, returns the speakers, and that's where our lovely inner join function, that fairly complex looking thing, came from before. But here, this is how we actually join these two arrays together. Yeah. So here it's going to. So we see it's kind of curried. It takes the string, which is the property that we want to, that was the speaker property on the talks. The string, which is the property handle on the array of speakers. And then we are waiting for the talks and the speaker arrays to be given as arguments before we actually return the actual result set that we care about. So demo time. So here I'm actually going to just show you the code base. Don't worry, it'd be really overly complicated and no one will understand it, but I'll just show you anyway. So let's see if I can swipe past.
3 fingers.
There we go. Right. So this is it. Massively complicated. So this is our entire search function. So if you were thinking about where do we do composure, we do from right to left. So here we're working from bottom to top. Yeah. So at the very base of it, you can see our search function right at the bottom, including our type signature. So here we have the talk query, returns the result set that we care about. So if we look at it, we're actually composing those two asynchronous operations that we talked about earlier. Yeah. So if I work from top to bottom, bottom to top, Christ. So find talks, the first thing that we do. So find talks takes that talk query, it passes to the Elasticsearch client library. Here I've just wrapped it so that it returns a future. Yeah, if anyone asks later, I can show you how we wrap all that. But I've got a client library there which just returns a future type, which resolves to the values to the talk values that we care about. And then we map over that. So what you're doing here is that you're mapping over the resolution of the future. Yeah. So Elasticsearch search is going to return you a future, which is the result set that we care about. And then we're just going to map over that future and apply the function which is actually going to be applied against the resolution of that future. Yeah. So here, past results is using those, now combining those two utility libraries that Andreas covered in his one, path and pluck. So path here is actually, if you look at the type signature, it's going to extract the property hits value until it gets back the array of the source the source array that Elasticsearch has got. And then we have our and then we're going to compose that with pluck so that it extracts the property underscore source, which actually returns the talk values that we care about. So you can see that as you compose those, you actually end up fitting the type signature that we care about. Yeah. And so if you look at find talks, it basically, you can see how it conjoins the input arguments from one to the output arguments of the last one so that it fits that type signature. And then let's look at add speakers. So here, this is where we can do some nifty partial application. Yeah. So the first thing it's going to do, it takes the talks array, and then from that, we're going to pass it to find speakers from talks. So that function is actually going off, and it's composed of two more operations: Mongo query from talks, and actually the Mongo client library to actually search in the speaker collection. So Mongo query from talks takes an array of talks. If you look at the top, Mongo query talks and returns a speaker query. So here, we're going to take that list of talks. We're going to pluck out the property of the speakers, which was just those GitHub handles. And then we're going to pass that, and we're going to generate a Mongo query object. So here is actually going to do a contains query. So it's going to say, look for all the speaker objects, which basically contains where the handle value is matching any of these speaker GitHub handles that I've got here. Yeah. And from that, we actually generate out the query object, which we then pass to our Mongo library to actually do the asynchronous operation. So here it returns a future of that list of speakers. So that returns it back to add. If you look at back add speakers again, so what we're going to get back there is a list of a future type resolving to a list of speakers. Yeah. But let's take a look at inner join this time. So remember, if in the inner join we took two properties and an array of talks and an array of speakers. So here we're partially applying the first three arguments. So if we partially apply the first three arguments, what we're expecting back is we're getting back a function which expects the last value. One more argument, which is the array of speakers. Yeah. So here, what it's going to do is it's going to map over that list of speakers, yeah, which it's expecting, and then it's going to join those together. Yeah. So here we can actually compose and partially apply just the talk, so we're only expecting a list of speakers back from there, and then we can actually join those all together and return the result set back. So if you go, and so you see that is the last function that is actually part of the compose chain of our original one. So here you can actually search, and the search is just all it's returning is a function which resolves to a future type. And that's really our entire microservices described, all that complexity of all those asynchronous operations, all of that composed into one simple function that we can just export now and use however we feel free to use, like to use. So you can see that with this, it keeps our code really terse, really descriptive as well. We've broken down all our individual operations with very clear and concise naming convention for all of those. The type signature describes everything, that all our input values and all our resolutions to those values. And then we can see how we can compose, and like Lego blocks, we can kind of join them together and compose them all together to actually generate out the operation that we need. So how do we actually end up invoking this? So remember, all we return back from this whole chain is a future type. So if we go back, if you look at an Express application, our handler is no more complex than this. So here, we've just imported that function. We've taken an input query, which is basically wherever the query string parameter we may have been passing this handler, and then we fork it. And here, this is how we handle our error status and our error result, and our result set. We pass it back here. So with this, we've basically pushed all the side effects, all the execution, all of it, right to this handler. We don't perform any execution until this gets invoked. So our entire microservices is basically a description of all the operations that we want to do, but we don't have to actually care about how we handle all the error handling, exception handling until right at the end, and when we actually care about actually wanting to deal with it. So here's where we actually end up sort of managing all of that. Yeah. So we can go off and chain all our futures and everything together, but we don't actually have to do any exception handling until the point at which we really care about is when we want to return the error back to the user, whoever's consuming the microservices. So I can give you, I'll just display the demo application, which is talkfinder2000.uk. You feel free to go to this site. We went and bought the domain crazily for it. And it's hosted on my EC2 instance, so don't rag it too much because I'll end up paying a big AWS bill, but feel free to do it. So this is lovingly programmed with a beautiful front end built in Elm, which I had no idea about. I would have chosen React, but Andreas loves Elm, so we're going to hear it. So here we have a lovely front end application. So here you can type any search term that you want, and it's going to do a search on Elasticsearch. It's going to look through all the descriptions, all the titles, and give you the results set back. So what we all hear listening tonight is functional programming. So let's look for functional. Hey. And yeah, and he came up, and Andreas was really pissed that he was too quick because he had a lovely little spinner and everything to wait for data. I'm sorry, I couldn't slow that down. It was like 6 milliseconds. I couldn't make it any slower for you, but there you go. So yeah, and here we have all our list of results sets coming out. So beautifully, you've got links to GitHub. So it has all the GitHub URLs that you might want to link to. So you can hear, all my code will be in my repo there. We'll put it up later for you so you can have a look at it. Just to know there's no tricks. We're not doing anything special with it. So yeah, we have our little handles and everything down it. And if you click more, you can actually see the description. And it actually displays all that text. So all that is being returned from our endpoints. And just, I don't know if this will work, but let's see if we can actually go to the endpoint itself. Yay! And you can see all that the data being returned there. Yeah. So really what I want to take away from this talk is that building a microservice application in these functional patterns doesn't have to be overly complicated. Yeah. What you get is that you get very succinct, very terse code, and you get a way of dealing with all your exceptions that you can deal with that right at the end. You can push that all to the edge. Yeah. You don't have to handle any of that up front, and you can. And in terms of like being able to test all of this, it's very, very easy to test. You can actually test. You don't have to test your client libraries. You don't have to test any of that. You can just literally test all your operators, your functional transformations. And you can do that all in your unit tests, and you don't have to mock anything or do anything and stub anything out. So yeah, so here it's just showing that you can actually build very, very concise, terse code from following a functional pattern rather than building sort of very large monolithic applications. Okay, so that's it for me.